All right, so before we continue on with geometric series today, I would like you to find me the rule or rules, because remember the special case is in effect for the geometric sequence, almost said series, that's later, for the geometric sequence with those two terms. Okay, so find me the general rule. So that gets me, first one gets me negative 3 is equal to g sub 1 times r. Which, if I solve that for g sub 1, I would get negative 3 divided by r. Negative 243 1 times r to the 6 minus 1, or fifth. And then I can substitute in what I solved for g sub 1 for. So then that's going to give me that equation. When I simplify it, divide both sides by negative 3, gives me 81 equals r to the fourth. Fourth root both sides. I'm taking an even root, so that means it's plus or minus 3 is my r value. Which means I'm going to have to put in positive 3 to get a g sub 1, and I'm going to have to put in negative 3 to get a g sub 1. If I put in positive 3, I would get negative 3 divided by positive 3, which would give me negative 1 as my first term. So that would give me the rule g sub n equals negative 1 times 3 to the n minus 1 power. If I plug in negative 3, I would get negative 3 divided by negative 3. So I get positive 1 as my first term. So that would give me the rule g sub n equals positive 1 times negative 3 to the n minus 1 power. I would also accept here just negative 3 to the n minus 1 power because it's positive 1. On the other one, you got to have that negative 1. Or have negative outside the parentheses. Okay. Love it. So today what we're going to do then is we're going to shift off of geometric sequences, and we're going to go to geometric series. Okay? So we're going to add up geometric terms, or terms that have a geometric relationship. And unfortunately, I'm sorry, there's nothing that I can really do about it because it's just the formulas that we have. The two formulas are there. Okay? Either one of the formulas will work. It's just really a matter of what you want to find, what you want to have. Okay? So I'm going to give you a little bit of time here to write these two formulas down. Okay? And then there's what everything is, but all of the stuff that, what they are, we've seen before. So give you a little bit of time here to write those down. So the sum of a geometric series is either the first term times your r value raised to the nth power, then minus 1. All of that divided by r minus 1. Or the last term in your series times your r value, then subtract off the first term, and then divide that by the quantity r minus 1. Okay? Again, I apologize. Fractions are going to be your friend again today. Okay? On certain ones. On different ones, you don't have to worry about fractions. Okay? But if your r value is a fraction, you will have a fractional answer. Okay? There's just no way around it. Okay? So, where do we find the stuff that we need? Well, we've needed a couple of different things. So, we needed G sub 1. Well, G sub 1 is right there if I'm given the rule. G sub 1 in sigma notation, you've got to plug the bottom into the rule. And remember that this that right there in sigma notation, that's the rule. So in sigma notation, what comes after the sigma, that's the rule. So that's where we find the first term. We might have to find the last term. Whatever that is. If it says find the sum of the first 7 terms, we're going to have to plug 7 into our rule to find that last term. In sigma notation, we've got to plug the top into the rule. We need R. R is right there. Okay. In sigma notation, R is this something right there. It's the base of whatever you're taking the power to. Okay? So whatever's got the exponent, that term, that number, that's your R value in sigma notation. Just like in the rule, the R value is whatever has the exponent attached to it. Okay? We might have to find n in sigma notation. N is top minus bottom plus 1. Okay. Or if it's like in the direction, find the sum of the first 7 terms. 7 is n. Okay. Love it. Let's put it to work. Let's dive right in this. We got 4 examples that I would like to do today. I'm going to do, when I show them, okay, I'm going to do 2 of them using the top one and 2 of them using the bottom. Okay, so then it's even. But it doesn't matter which one you use. In the end, we're all going to get the same answer. Okay? It's like as if we were walking down a path, and this path goes around a lake. Okay? If you go to the left and I go to the right, and then we meet up on the other side, we're still going to be in the same spot. Okay? We just take a little different path to get there. Okay? So I'm going to go top one here. So if I'm going up top, then that's telling me that I need to first find G sub 1. So I'm going to plug in, oops, let me get that on there, have the brakes in there. So I'm going to plug in the bottom number here into my rule. 4 times 1/2 to the 1 minus 1 power. 1 minus 1 is 0. 1/2 to the 0 power is 1. 1 times 4 is 4. So my first term is 4. I need my R value. My R value is whatever it has the exponent attached to it. That is 1/2. I need my N value. N is going to be 6 minus 1 plus 1, which is just 6. We can now find the sum of the first 6 terms. And that's going to be equal to my first term, which is 4, times my R value, which is 1/2, raised to the n power, then minus 1, all over 1/2 minus 1. Good times. This is 4 times 1/2 to the 6th power is 1 over 64. Right? (1/2) minus 1 is negative 1/2. When I'm dividing by fractions, I multiply by the reciprocal, correct? Yeah. So if I multiply by the reciprocal, this would be 4 times that number, we'll get to it in a minute, times negative 2 over 1. Well, I'm going to take this, but I'm going to write it like that. Why did I do that? Nope. Common denominator. We're going to add and subtract fractions. We got to have a common denominator. So 64 divided by 64 is 1. So it's the same thing. Yeah? So 4 times negative 2 is negative 8. 1/64 minus 64/64 is negative 63/64. Eight goes into 64 8 times. Negative 1 times negative 63 over 8 tells me that the sum of the first 6 terms is 63/8. And we leave it in fraction. Okay. Good times. Utilizing that, please try this one. Find the sum of the first 10 terms of this geometric series. So I'm going to do this one using the bottom one. So the first thing that I need to find is G sub n. So G sub n, in this case it would be G sub 10. I'm going to plug 10 into my rule. Ten minus 1 is 9. 1/2 to the 9th power. I'm going to need one on this one too. Come on. Why did I do that? Come on.
You have to swipe down on it. There should be a lock then.
No, it's not locked. I don't have rotation lock on.
Did you log into your phone?
Yeah.
Did you
Oh
log-
no, that's why. Because I just swiped in. That's why. There we go. See, there it is. 2 to the 9th. I mean, somebody could have given it to me in this time, but you know, we'll figure it out anyway. It's 512. 1 over 512. So then times 4 would be 1 over 128. Okay. My R value, what's my R value? R value? Half, yep. The term that's got the exponent on it. My first term, I'm going to plug in 1. So that's going to be 4 times 1/2 to the 1 minus 1 power. 1 minus 1 is 0. 1/2 to the 0 power is 1 times 4 is 4. Okay, so the sum of my first 10 terms is going to be my last term, 1 over 128, times R, which is 1/2, minus my first term, 4, all over 1/2 minus. So that's 1/256 minus 4 all over negative 1/2. So that is 1/256 minus 1024. Yes, over 256 times negative 2 over 1. That's negative 1023 over 256 times negative 2 over 1. And so the sum of my first 10 terms is equal to 1023 over 128. Yes? No? Maybe? Love it. Yeah? Try that one. I'll go back to using the first one. My first term, I'm going to put the bottom into my rule. 10 to the negative 2 to the first power. Negative 2 to the first power is negative 2 times 10 is negative 20. My R value is negative 2. My total number of terms is 15 minus 1 plus 1, which is 15. So the sum of the first 15 terms is going to equal my first term, negative 20, times my R value, negative 2, to the 15th power, minus 1, and then negative 2 minus 1 on the bottom. To the 15th power is, so this becomes negative 20 times negative 32,768 minus 1 all over negative 3, which is negative 20 times negative 32,769, all divided by negative 3, which is negative 20 times 10,923, which gives me the sum of the first 15 terms is negative 218,460. Yes? Much easier when bars are that way. Okay. One last one to do. Find me the sum of this geometric series. And I will do this one using the bottom. So my last term is I take the top and I plug it in. 2 times 3 to the 7 minus 1. 7 minus 1 is 6. Three to the 6th power is 729. 729 times 2 is 1,458. If I am not mistaken. 3 to the 6th power times 2. 1458. Then I need my R value. My R value is 3. Then I need my first term. Again, put 3 in there. 2 times 3 to 3 minus 1 power. 3 minus 1 is 2. 3 squared is 9 times 2 is 18. So the sum is going to be the last term times R minus the first term all over R minus 1. 1,458 times 3 is 4,374 minus 18 is 4,356 divided by 2 is 2,178. Agree? Okay. Again, I remind you that formative 7-1 was due yesterday. And I remind you that quiz 7A is due on Sunday night. Okay? And that quiz is actually open right now. Okay? That quiz is open for you now. You have all day tomorrow, all day Saturday, or all day Sunday to take it. It's a one-shot deal because it's a summative.